So in today's video, I'm gonna be teaching about chemical bonds, form of chemical bonds. So the first one we'll be looking at is ionic bonds, and then we're gonna be looking at covalent bond. And metallic bond. Of course, there are many other bondings, but we're gonna first look at these three. Yeah. So firstly, we'll be looking at ionic bonds. As you can see here, the definition says that the electrostatic force of attraction between oppositely charged ions formed as a result of the transfer of one or more electrons from one atom to the other. So this would be the definition of ionic bond, and the ones that are highlighted are the keywords of the definition. So you have to remember that there is an electrostatic force between oppositely charged, means there is metal and non-metal bonding. Yeah. So they are also known as electrovalent bond. Like I said, formed between metals and non-metals. So as you guys know, metals all have positive charge, and non-metals all have mostly have negatively charged. So for positively charged, they usually lose electrons, and for negatively charged, they usually gain an electron. So as you can see here, electrons in the outer shell of the metals atoms are transferred to non-metal. So to achieve a full outer shell has to be either 2 or 8 in most cases. So let's see, for this example, there's three atomic numbers for this metal, and for the non-metal there would be, let me put a different 3, 4, 5, 6, 7, 8, 9. So as you can see here, the outer shell would be 1, and here it would be 7. So in theory, as you know, the outer shell can only be full if there is if there's 2 electrons in the outer shell or 8 electrons in the outer shell. But in this case, metal only has 3 and 1 in the outer shell, and non-metal has 7 only. So how do we make sure that both can fulfill the full outer shell? So metal will give away 1 electron in this case. So now metal form only has 2 electrons in the outer shell, and it will be a positive because it's giving away 1 electron. So giving away 1 electron, it will be a positive. Accepting it will be a negative. So now non-metal has 8 full outer shell in this case. So this would be a negative because it is accepting electron. So in this example, we'll see sodium chloride. As you can see here, sodium has 1 electron in the outer shell. That means the full outer shell is not fulfilled because, like I said, it has to be either 2 or 8. So in this case, for sodium, it has only 1, and for Cl, it has only 7 here. So how do we make sure that both of them are fulfilled? So as you know, metal can only transfer to non-metal. So we can transfer 1 electron from sodium to chloride, and as you can see here, they are both fulfilled. Both have 8 at each full outer shell, and this would be the ionic equation. Because Na would be losing an electron, that's why electron would be after the arrow. And electron would be before the arrow if they are gaining an electron, because here means losing electron, here means gain electron. Yeah. So same for magnesium oxide. As you can see here, now the charges are different because this just means we are removing 2 electrons and we are gaining 2 electrons. Yeah. So for this third example, as I've mentioned, you can only have 2 or 8 electrons in the most outer shell. However, in this case, there are 2 electrons in the most outer shell. So you may be wondering, oh, isn't this fulfilled? No, but because the innermost shell will have maximum of 2 electrons only, so only this shell can have 2 electrons, so the other shells needs 8 electrons to fulfill the full outer shell. So yeah, in this case, we have two electrons, the outer shell. That means we are not fulfilling the full outer shell. That means we have to donate the electrons to our non-metal, which is fluorine in this case, and it's perfect because we have 2 fluorine, as Ca is a plus and fluorine is a 2 negative. So if you cross these two, it will be it's the other way around. 2 plus and minus. Yeah. So if you've learned this, you're supposed to cross the CaF2, as 2 goes over to the F and negative, and 1, the coefficient of the -1 goes over to Ca. So in this case, we will have 2F. So you will obtain this ionic bonding. So now we're gonna be learning about the dot and cross diagram. So dot and cross diagram is a diagram that the arrangement of the outer shell electrons in the compound. It shows the outer shell only. That means if we have, let's say, aluminium, it has an atomic number of 13. So as we know, the rule says our first shell has to occupy 2 electrons. Our second would be, the rule is 288 rule. So this is first shell, second shell, and third shell, and so on. So our second shell can have 8, and that will add up to 10 in total now, and then we need 3 more to obtain 13. So now we have 10, 11, 12, and 13. So dot and cross diagram means that we completely ignore this part. Yeah. So we only take the outermost because that's what actually matters, as the inside, the one that I have outlined, has full outer shell, so we can ignore that, as we cannot transfer or gain any more electron inside that. Okay. So charge of iron is spread evenly by using square brackets. So square brackets means this. And charge of each ion written at the top right corner of the square bracket. So it's x plus or minus. Al would be 3 plus. Yep. So here, as you can see, you can do it any other way. You can either draw a dot and cross, which is this part, the first part, or you can draw the electrons around the element. Yeah. Because both ways work as well, as long as you don't include the inner fulfilled shell. So now let's test ourselves with this. So we have potassium oxide, and we're meant to draw a dot and cross diagram. So for potassium, we know potassium is a K plus 1. For oxide, we know is 2 minus. So if you combine that, it's K2O. So we know that there's 2K and 1 O. And we have 19 atomic number, but if we consider dot and cross, that means only considering the outermost shell, we would have this K and this K. And for oxygen, we would have 1, 2, 3, 4, 5, 6 only. Wait, let me put this and dot so it's easier to see. So in this case, K would be the metal and oxygen would be non-metal, and like I've mentioned earlier, electrons will be transferred to the non-metals instead. So in this case, we know that oxygen is missing 2 electrons. So where can we get it from? We can get it from the potassium. So we put here and we put here. So that will give us plus K plus and two minus. And your metal can have 0 outer electron.